Hey everyone. So in this video, I'm going to introduce you guys to the PPC model. We actually have, this is the first of 3 sections that's on the PPC. This is a pretty important model for macroeconomics. This is our first model that we're eventually going to use to demonstrate the entire economy. Now we start off with our PPC, we just have a PPC that shows 2 different things. But eventually we will make this bigger, and we will have it represent the entire economy. But for right now, on our PPC, what you need to know is that we've got a Y and an X axis, and we're going to put 2 things on those axes. Now, there's not an independent and dependent variable here. The PPC is weird and different in that way. There's no independent dependent variable. You just have 2 codependent variables. So the more you produce of one, the less you get of the other. Now, I've got a couple of examples here. So I've got TV shows and movies on one PPC, and then I've got soda and cups on the other PPC. So if we're talking about TV shows and movies, they use the same resources, right? Actors, directors, cameras, writers. So they use the same resources, but a TV show is shorter, so you could produce 4 or 5 TV shows for each movie that you make. So what we end up with is something that looks like this: a straight line PPC, because they use the same resources. So what this list right here is saying is, for every 4 TV shows you give up, you can make 1 movie. There's a constant 4-to-1 ratio there. So it's a straight line because it's a constant ratio. But soda and cups uses way different resources, right? Cups can be made out of glass or plastic. Soda is going to be, it's going to be food coloring and water and corn syrup, most likely. So you can make plastic cups out of corn, You can make corn syrup out of corn. So there's a little overlap there between soda and cups, but they're pretty different things. So what you get instead is you get a curved PPC. Because the more cups you produce, the more soda, to make more cups, you have to give up more and more and more soda to do it. And to make more soda, you have to give up more and more and more cups to do it, right? Now, usually the most important resource is labor. And so the way to think of this is some people are better at making soda, some people are better at making cups, and then some people are maybe okay at both, and some people are and so when it's time to make soda, we're going to pick the best soda workers who are also the worst cup makers. And we're going to have them make soda, and they're going to produce lots because they're good at it, right? And as we start grabbing more and more labor to make soda, we're going to have to eventually get the people who are good at both. So it's costing us more cups to make that soda. And then eventually we're going to have to get the workers who absolutely suck at making soda and who are great at making cups. So we're going to get very little soda out of them, and we're going to give up lots of cups to do it. So that's why this one is curved. So straight line PPC, constant opportunity cost, means you use the same resources. Curved PPC is an increasing opportunity cost, and it means that you use different resources. Now, there's other concepts that we can show on this graph as well. So let's dig in at an example here. Let's focus in on our soda and cups example. So I'm going to make a big soda cups PPC, and I'm going to put some points on here. So I've got my PPC here for soda and for cups, and there's other unit 1 concepts are built into this model. So for instance, scarcity, right? How do we see scarcity on this graph? Well, what this graph shows us is if I want to produce, I can produce, this, let's say this is, 100 liters of soda, and this is down here at the extreme is 1,000 cups, right? So as we look at this graph right here, this is saying I can get 100 liters of soda if I want. I can get a little bit less. That looks like maybe 90. And I can get maybe, 100 cups and 90, liters of soda. Or as we continue moving, we can get different combinations. But what I can't do is I can't get 1,000 cups and 100 liters of soda. That A, B, C, E, F, G is point, writing upside down. That point G right there, that's outside the curve. That's impossible, right? Because of scarcity. We don't have enough resources to do 1,000 cups and 100 2 liters of soda. We have to choose one or the other, which then brings us to some other unit 2 concepts like trade-offs, right? We can get A or B or C or D or E or F, but I can't get B and C, right? That there's trade-offs here. I can pick any one of these points, or I can even put, I could even get point H on the inside if I wanted. Can't get point G, but all of these other points are all trade-offs. We can see opportunity cost on here as well. And I think the next section is going to go over that in more detail. But for opportunity cost, right, if I move from point A to point B, I'm going down my y-axis to go out my x. So I'm giving up, I don't know, maybe 10 liters of soda to get 100 cups. So that's my opportunity cost, is that I gave up 10 liters of soda going from A to B. When I go from B to C, maybe I'm giving up 15, 20, 2 liters of soda to gain another 100 cups. My opportunity cost is getting bigger, right? So if this is, maybe this was 5, this right here is going to be 15. So we went from 95 and 200 to about 85, or about 80 and 500, something like that. I don't know. But the opportunity cost is what we gave up. So we can see that concept on here as well. So how does this graph show efficiency? Well, any of these points on the curve, at any of those points, we're getting as much as we can out of our resources. So whether it's point A, if we want all soda, right, then A is efficient. We're getting as much soda as we can. Point D, a little bit of both, or point C, a little bit of both. That's efficient as well. We're getting as much out of our resources as possible. And point F is efficient as well because we're getting our most out of our resources. Now that's productive efficiency. Anywhere on this line is productively efficient. We're getting as much out of our resources as we can. But you might say like, well, A is not a very smart choice. If we have 100 2 liters of soda and no cups, how are we going to drink it? Okay, so maybe the best combination for society, maybe B is the best, where we have 95 2 liters of soda and we have 100 cups that we can use to drink that. Now, it depends maybe how many people that we have coming to our party. Maybe this is not the best combination right here. Maybe C is the best combination. 500 cups and 85 2 liters of soda. Maybe that's our best combination right there. So that's allocative efficiency. Whatever's best for the given society is the allocative efficiency. But productively efficient, that's easy to find. It's any point that's on the curve right here. Now, when I was in college, my professor called this the production possibilities frontier because this line right here is the frontier of what is possible to produce. This is the edge of what is possible to produce. But anywhere inside can be produced as well. It's just not as efficient. So like we can have a point right here, 52 liters of soda and no cups, but that's not as good as 100 2 liters of soda, but it's still possible. So anything under the curve or anything inside the curve is possible. Anything outside the curve is impossible or unattainable, at least for now. All right. I'll see you guys in a minute.